Alright guys, I hope you are bundled up and ready for the winter weather because it is cold outside. Today we're going to be talking about solving compound inequalities. Let's go ahead and remember some of our very important concepts. First of all, remember when you're solving inequalities, you need to solve them exactly how you would a normal equation. Also, when you're graphing them, you need to know when you have an open circle or a closed circle. You'll have an open circle when you have a less than or a greater than symbol. You close it when you add that equal sign underneath it. And never forget, if you multiply or divide both sides of that inequality by a negative, you have to flip your symbol. Some new concepts that we're going to be talking about. If you see the word "and" in your inequality, in your compound, you're going to find where both lines intersect or cross over each other. When you see the "or" symbol, it's going to mean that at least one of those lines will cross. Okay, so we'll go ahead and look at some of those. Let's go ahead and concentrate first of all on the "and" compound inequalities. Here's an example. Example 1. When you have x minus 3 is greater than or equal to 2, negative 2, and x minus 1 is less than 4. We solve it like we would a normal equation, and we get x is greater than or equal to 1, and x is less than 5. Let's graph both of them in different colors. So I went ahead and graphed my blue with a closed circle because it's got the equal sign underneath it, and it is greater than, so it's all the numbers greater than 1, and it's pointing to the right, so we're going to go ahead and draw that line. When we have no equal sign, we're going to go ahead and leave the circle open. This is pointing to the left because it represents all of the numbers less than 5. So we would have it going this direction. On the "and," they are intersections. So where do those lines overlap? This green area is where they overlap. Both the red and the blue are crossing on the 1. So that is a filled-in circle. We also have an open circle here, meaning that the red line does not go through 5, goes all the way up to it. We also have the blue line going through it. So we leave an open circle here. Where do they both intersect? Right here, between 1 and 5. Let's do this one together. First of all, it looks a little different than this. They put them together because it's the compound inequality. So let's go ahead and rewrite them where they're not together. 6 is less than or equal to r plus 7. Then we also have r plus 7 is less than 10. And we're going to go ahead and solve it, again, like a normal equation. So I'll subtract 7 from both sides to cancel that out. That leaves me with negative 1 is less than or equal to r. I don't like that because it's hard to graph sometimes, so let's go ahead and write it in proper form, where our r is on the left side. So we have an r and we have a negative 1. The mouth, or the greater than symbol, is going towards the r, so we need to make sure that it is the same direction when we rewrite it. There is that inequality. Let's go ahead and graph the other side. When we're solving this one, we're going to subtract 7 from both sides. R is left over here, and 10 minus 7 is 3. Alright, let's go ahead and graph these. The blue one should be a closed circle because it is equal on the negative 1. And it is pointing to the right because it is all of the numbers greater than negative 1. This one will be an open circle because there is no equal sign. So open circle on the 3, and it's pointing to the left, all of the numbers less than 3. Again, we're looking for the intersection. Where do they overlap? So right here, we're going to go ahead. Both of these lines will cross on the negative 1. And this does not include the 3, so we cannot leave that included, but it's all the way up into it. So we're going to go ahead and put an open circle there. They overlap all of those spaces in between. And that is our solution. Let's go ahead and look at some that have the "or" symbol. In example 3, we have negative 2m plus 7 is less than or equal to 13, or 5m plus 12 is greater than 37. Again, we're going to solve that as we would a normal equation. So we're subtracting 7, and we're left with negative 2m is less than or equal to 6. Then we divide by that negative 2 on both sides. Don't forget, whenever you multiply or divide on both sides by a negative, you have to flip your symbol. So instead of a less than, I moved it to a greater than or equal symbol. All I'm left with is an m, and 6 divided by negative 2 is a negative 3. Over here, we are subtracting 12 from both sides. That leaves us with 5m, because our 12's canceled out. 37 minus 12 is 25. So we have 5m is greater than 25. I did not flip it because I did not multiply or divide by negative. To solve this, we're going to divide by 5 on both sides. The 5's will then cancel out, leaving me just with an m. 25 divided by 5 is 5. So when I'm graphing this, I graph a closed circle on the negative 3, and it's pointing to the right. All of the numbers greater than negative 3. Over here, I'm going to have an open circle, and it's, again, all of the numbers greater than 5 this time. So it's going to also be pointing to the right. In the OR statements, again, we're looking at lines where it's just at least one line. They do not have to both be over it. So there are no lines over on this side, but we have at least one starting at the negative 3. That is included because it's filled in, so we're going to go ahead and fill in our circle here. And at least one line crosses all the way to the right, so our line will go forever to the right. Let's look at this problem together. We're going to go ahead and solve this by subtracting 1 on both sides to cancel out our 1. That leaves us with a. Over here, 4 minus 1 is 3. I did not multiply or divide by negative, so I'm going to leave that symbol in the direction that it was going. And let's go ahead and graph this. Again, it's an open circle on the 3, and it's all of the numbers less than 3. So it's going this direction. When we solve this other inequality, we are going to add 1 to both sides to cancel out our 1's. That leaves us with a is greater than or equal to 3 plus 1, which is 4. And when we graph that, we're going to have a closed circle on the 4. And it represents all of the numbers greater than 4, so we are going to shade it to the right. Remember, this is where at least one line will be over that number. So this one has nothing on the 3, but it's all of the numbers up to the 3. So our solution would be these numbers, as well as these numbers, because at least one line is over those as well. Now that is how you graph statements with inequalities. Next time we'll be looking at word problems.